Considering the future and what it holds, renewable energy systems such as DC microgrids are being implemented more and more, not only on a large scale but also at one's homes. With that came to mind to design and implement DC small appliances which can function directly from a DC microgrid without having to convert from AC to DC or DC to AC, eliminating the converting factor overall.
Some home appliances do function from a combination of AC and DC waveforms, as the system comprises out of different components requiring either an AC or a DC waveform. As the figure shows an example of having multiple connectors to meet the end requirements, which can then be seen as the conversion and rectification process from AC to DC and sometimes to AC again, results in energy losses as well as an increase in the production cost as the list of required components increase. A prototype of selections of a DC bean-to-cup coffee machine was selected for the demonstration purposes of showing the capability of having a system only function from a DC waveform. The explosion view shown can then be seen to represent the three main sections designed for a prototype of a DC coffee machine. The selections designed and implemented was the puck press, rotational mechanism and the water release system. A demonstration of the starting procedure of the machine will now be shown, where first off the system should be reset. Here it can be seen that the puck press is reset with an end stop, as well as followed by the rotating mechanism, where it will be triggered once the end stop is pressed. Once the end stop has successfully been pressed and the location of the disc has been determined, it will move towards the puck press location, where the filling of the coffee ground can continue. The coffee ground can then be inserted beneath the puck press with use of a syringe which has been cut at the end. The use of the syringe is to place the coffee ground at the center of the puck press. The puck press will then, after a countdown, start to press down on the coffee ground and stop once the force-sensitive resistor beneath the puck press indicates the correct force measured with use of calculation. Once the force has been reached, the puck press will reset and then moving to the final location where the puck is released into the portafilter. Complications arose where the stepper motor driver was not able to deliver the total 3 amps for the stepper motor to produce 9 kilograms of force to tightly compress the puck. It is therefore disintegrating and falling into the portafilter, not staying intact. Once the puck is into the portafilter, the disc resets by turning back to the end stop, where water can then be released with use of a solenoid valve, allowing for water to flow through the puck. The water flowing through the puck will now be demonstrated. It can be seen that the portafilter is removed to only show the water flowing through. The piping is then replaced back onto the rotating disc, which in the first place caused too much friction due to the type of the pipe, causing the rotating disc not to rotate completely. It is then shown that after the timer has completed, the water is flowing, which can be seen as the coffee entering into the cup.
For prototyping of DC small appliances, it can be found suited to implement DC appliances, since it eliminates some of the energy losses, reduces manufacturing costs, and also reduces the product cost at the end. Thanks for watching, and I hope you've learned something today.